Good morning, everyone. Today, we would like you to invite to our presentation, during which we will be talking about the SmartThings open platform for IoT solution.
Hello, my name is Ablewicz, and I'm a part leader slash senior software engineer in Home IoT solution part in Samsung.
And I'm Kopel. I'm a software architect, system architect in Samsung as well. So what we will be talking about today. Today we have a pretty short agenda. I hope you won't get bored. But basically we will start with Samsung and SmartThings introduction. Samsung, most likely you know, and I understand what's about this company, but SmartThings is something which is relatively not very well known, especially in Poland, as they are not present on the market yet. Then we will move into the idea, what's behind the SmartThings IoT open platform. So what kind of problems we are trying to address and what we want to achieve. Then we will be talking a little bit about the big high-level architecture overview of the platform to understand what's going on there. Then Mariusz will, I will take you and show you how developers can interact and participate in this effort and this ecosystem. And then Mariusz will show you a live coding demo showing how this works in practice. Hopefully everything will get better than our start. And I apologize for the delays. So SmartThings introduction. Talking about the IoT and the Samsung, multiple things comes to our mind. First, maybe something which is not really obvious, but Samsung is a big foundry company. So IoT is also a lot of chips devices we are producing, and we are selling to other customers. What else? We have an Arctic platform. So this is something which is Samsung homegrown, and those are ARM chips and full boards and different sizes, different capacities, which we are trying to and sharing with the world as a platform, as a foundation component for building an IoT devices. Then we have our home appliances. And home appliances are also IoT devices, even if they weren't a few years ago, 2 years ago. Right now, everything is connected to the internet, so they are really an IoT devices. A quick question, do you have an idea what's this? Those 3 towers. Not quite. This is no. Those are air purifiers. So the devices which are being put into house, into home, and their goal is to keep quality of the air, both from the humidity perspective and particles. I would say that the problems we are seeing even more and more in Poland and in big cities, I'm from Kraków, by the way, and they are also prominent and they are very significant market in Far East. So China, South Korea, they are using it. Okay, next one, Harman. So fresh, a few weeks ago, it was finally completed acquisition of Samsung. Harman, we are talking here about the IoT in terms of automotive devices. So info center, infotainment systems within the cars, but not also, but not all of them. And finally, SmartThings. So home IoT devices. This is our topic of our discussion, of our presentation today. Recapping the whole thing, there is a significant diversity within the efforts taken by Samsung in the terms of the IoT. And on the one side, this is a huge strength. On the other side, this is a huge challenge because those front tires, those components are coming from a completely different perspective and completely different history. So the idea is that, okay, on the one side we have a good diversity, and with this we are able to address different needs. But on the other side, the challenge we are trying to solve very hard, and I can promise, and maybe this is not really visible outside, but inside, internally in Samsung, we are working very hard to unify those items and to make them available to customers, to end users, to you, as a single item which can be manageable in a simple way. Short history about the SmartThings. Okay, because we have been talking about the Samsung, so let's move to the SmartThings. The anecdotal evidence talks about the whole idea started once the mountain home of one of the founders of the SmartThings IoT get flooded during winter. So they have started looking for a solution available in the market to prevent this in a future. Unfortunately, they were not able to find anything suitable. So they decided to create their own company, which will, they decided to solve the problem. And okay, once it turned out to be a reliable and working solution, they moved further and created a Kickstarter campaign based on this. Which turned out to be really a huge success. Even if they were asking only for $250,000, they got in a 1 month over $1 million collected. Pretty quickly, they have also got a recognition from the industry in terms of a Spark of Genius, winning a Spark of Genius competition. Of course, the prize here was something which helped to build the company, but I think that what was most important was publicity and recognition from the industry. Very quickly, they have started delivering the devices, delivering the whole solutions. They have started gathering customers around themselves. And by this, they have got into the radar of Samsung, which was trying to find a way to move into as many IoT technologies and areas as possible. So in August 2014, so basically 2 years after the Kickstarter campaign, Samsung bought the SmartThings. And right now the company is operating in Mountain View and sunny California, not always sunny, but sunny California, as a independent company, but with a very strong ties to Samsung. By the way, it wasn't disclosed officially, but unofficially the acquisition was in around $200 million. So after 2 years, from $1 million to $200 million, I think. Okay, moving to IoT platform. So what's the whole idea behind this technology, behind this company? As we are looking at will this work? Okay, as we are looking at the stack, what is needed to really have an IoT working, because IoT we can see as customers, as users, as devices, but to make them work, we really need to build quite a bit of software and hardware, data centers, etc., etc. So looking at this is a pretty much complex and complicated. On the other side, the idea is, okay, it's nice to get something which is working in a way how the producer and originator created a particular device, but we like to tinker with things, and always we are finding a new applicability, new ways to use them, and then it's very, very nice to have ability to really transform, change, adapt those devices to what we really want to do with them. So this is what was and is still behind the goal of the SmartThings. We want to have an open development platform, because only then the IoT will be really something which will thrive, which will be gathering more and more attention, market, and also which will be useful to us as we are using it. And in the words of Alex Hawkinson, so SmartThings founder and still CEO, this is a platform which brings together third-party developers, device makers, and consumers. What's the idea about the device makers? Well, if we can provide to the device maker something which will take care about the processing, the software part, etc., and let them focus only on building devices and connecting them with some standards to our net, this will help us spread IoT adoption. This will definitely help because, well, we have as we're always in the world, guys which are very skilled in particular items, and given that they will, to really get a success and get to the market with a device, they will have to take care about the remaining pieces which are not their strength. This is something which is really hindering and impairing development of those things. So the idea is, okay, we want to create something which will be open, will take care about all the processing part, and then within this, either developers and consumers have an ability to play with those devices and change them and connect them and make the new use of them, just playing within the software part. And then on the other side, we have a easier path to create something and introduce new devices into the market just for the other producers of the items. So how it looks like for the SmartThings open platform. So the critical part is cloud-based IoT platform. So there are many items, a lot of software, it's AWS based. So this is how it works. Devices can connect either through the hub, so part of the set which is being sold to customers is hub. This hub ensures connectivity with the sensors, with the devices, and then on the other side ensures connectivity with the platform. Some devices may have an ability to connect via IP directly to the platform. And there are some devices, I'm sure you understand and you recognize this device, have their own big ecosystems, and then we have an ability also to work with them together as a system-to-system interaction. So this is one part. This is part how the devices can talk to the IoT. But we are a human. We cannot really distinguish between the levels of the voltage and this kind of stuff. So we need something which will help us control and direct and understand what's happening. So we have a user interface which is possible on both mobile phones and computers through the web browser. Critical part, the devices, why hub is necessary, because many devices don't really talk via Ethernet or IP or anything else. They use Zigbee and Z-Wave IoT devices. So this is how we are translating this information and connecting those devices with a IoT platform. Okay, so this is the general idea. Create a platform, take care about the software, take care about the managing it, and let users play with it, and let other producers, other companies build devices which will help us on a daily basis. How it looks like from the architectural perspective, and well, the system which is put on a cloud, and effectively everything which is beyond the hub connectivity and even client connectivity. This is everything which is on a cloud. To some extent, this is a little bit against the fog computing paradigm, where the idea is, okay, we are trying to push as much as possible of computation into the devices. But, well, the idea is we don't want to make creation of the devices complex. Devices should be simple. Devices should use Zigbee, Z-Wave to communicate with hub, and let's take care about everything inside of the cloud. The second part is within the cloud, it's much easier to change, to adapt, to create new things. If we will have to put at least part of this stack on a hub, then it will immediately bring up problems related to how to update this software, how it will be working, will it be reliable or not. All these things are much easier, much better addressable in a cloud. But on the other side, we are working with we would like to work with multiple different devices coming from different vendors. So it's not just our devices, I mean SmartThings or Samsung devices. We would like to work with as many devices as possible. So at some point, what is necessary is normalization. So let's stop talking about the very particular features of some devices. Let's try to create some abstractions, and this way help manage them as a kind of the abstraction. So this part of the normalization happens on a device type handlers. It helps us to build a system which will control lightning. And we just can issue a command turn on light without really going into details. Okay, is it a Philips or is it a Osram or anything else? Next things. Okay, so having a kind of the abstraction, we need to take care about the logic, because this is where the strength of the platform lies. We have a practically unlimited possibility to build logic and build systems which will react on what's happening and what has been detected by sensors or devices in our world and influencing other devices. So this is what is happening here. Smart app management and execution. Smart app is the concept. This is, well, you may say this is kind of the program, but it's not really a program. It's more like a set of event handlers. We will talk about this a little bit later.
Show it.
How it architecturally fits into the overall concept. But the general idea is, here is the place when you are deciding how your system is acting. I mean, if there is a motion detected by sensor, what should be done with this information? Should it raise an alarm? Should it turn on the light? Should it start brewing coffee because you have just returned home? Everything here is possible, and everything is being done on this layer. And well, we have two places. Not on every piece of this architecture and the system we can allow customers and folks from outside interact. But there are two critical and two most important places. So first is device type handlers, and the second one is smart apps. Let's say we will take a customer-oriented focus. So from our perspective as a customers, the most important part is the smart apps. So this is how we are defining logic. And this is the place where the logic, how our system works, is being defined. For the device type handlers, this is something which is, also available to us as a customers, but it is much more important to vendors which will be producing new devices, new sensors, new things which will be connected, because this is where the normalization happens. So they know exactly what the device is doing, how it is working. Their idea is also to make sure that those device type handlers can be used by us in a standard way using some normalized activities. Okay, so we have gone very quickly through the overview, understanding, foundation. Where is the place for my code? Because, well, we are developers. I'm less of developer recently, but still have some bits of developer in me. By developing smart apps, for the development of smart apps, the decision was taken to use a Groovy. So basically what we have on a SmartThings platform, we have JVMs which are executing a Groovy code. And this is dangerous. This is dangerous because, well, if we will let unlimited code being executed on our platform, that would very quickly lead to hacks and abusing functionality of the system. So basically, okay, this is a groovy, but on the other hand, there are significant limitations imposed on how this groovy will work. The idea is that, okay, to reach our goals, to achieve our goals of controlling the systems and making sure that the devices are working and interacting with them, those limitations are not really a problem. Those are limitations caused by the fact that, okay, we want to make the system work flawlessly, smoothly, and quickly without many interruptions. On one side, this made, if you will get through this, so it looks like no global, no threads, no system, no files, no closures. Even if we will have some whitelisted classes, not all methods within those classes will be allowed to be executed. It seems pretty rigid. But on the other side, this is not a generic purpose platform. This is a platform to make sure that our IoT devices are working. And for this, it's not a problem. It's absolutely sufficient to make sure this is working. On the other side, getting back to the idea that, okay, this is a platform for developers, there is always a possibility to reach for a SmartThings team, either via forums or directly, and talk with them about, okay, to make sure that my device, I have a good idea how to make use of some devices, but I'm missing some pieces of code. Can you turn on or enable this code for us? And they are open for such a discussion. It's not a guarantee, because always security is important and not breaking things which are working so far. But basically, this is there is a place for not just company-driven or SmartThings-driven changes within this platform. There is a place to build this platform for a purpose and how the developers would like it to be. Okay, so the next part. So okay, we are writing in Groovy, and what we are writing? We are writing a SmartApp. So the SmartApp is the key point for us as developers. This is how we are collecting and putting all the logic to control our devices. From the perspective of developer and programmer, what is really important is that they are being really invoked as events. So there is no continued execution of the process or of the program. There is no kind of process. This is all just a set of callbacks which are being invoked in order to, well, when the criteria for their calls are being fulfilled and happened. So quickly going through the SmartApp lifecycle. They are being installed from the marketplace. So this is a very similar concept which is common on mobile phones and in mobile world. You cannot really bring a completely different application. The application must come from the marketplace. However, in the marketplace there is both space for the public applications and your own private applications. Once you decide after some tinkering and playing and tuning that you have created a very genius application which is helping solving some problem, then you can definitely ask to move your application from the private space to the public space. And also on the other side, you have an ability to share your application with others within the whole system, with other users of the SmartApp. Once the SmartApps will be installed, it will subscribe to very specified events. So you as a developer has a full ability to control to what events the SmartApp should respond. And what is most important, no continued execution. The question is how we are then keeping a state. Because, well, sometimes the solutions we are trying to solve are something like, okay, after 2 seconds, if there is no movement in a particular area, I want the lights to be turned off to save an energy. So this is something which is very difficult to resolve if you have just a handles and just a callbacks at hand. The solution for this is in a form of the state, atomic state. You can think about this as a kind of the context. So the situation is that there is a possibility to put some information, put some data in a context. This data is being stored as a JSON information. Well, according to the documentation, it's about 100 kilo for the JSON. So it is sufficient to solve standard problems and the standard logic which is required. And within this state, all the information can be stored between the independent invocations of the particular events. Of course, because we are developing our application, so there is a possibility to update it once the new version is available in the marketplace. And well, if we will find some application completely not suitable for us, definitely we can uninstall it. Okay. And showing it in a slightly different manner, those are the most important players. So we have a hub, and behind the hub there are some sensors, devices. Then we have a SmartThings platform, so there is an internet connection. SmartApp effectively is working inside the SmartThings platform, but just for the purpose of the interactions it is taken out. And then we have a mobile phone, which is well interface to the user. Within the SmartApp, we have a parts like a preferences and then definition. So those are the items which are helping us establish a SmartApp within the SmartThings platform. And then we have a lifecycle callbacks and event handlers. So the code which is helping us code logic related to this application. So the preferences definition on the one side defines the event subscription. So here is how we are defining what kind of events we are interested in. There is a metadata information about the SmartApp in general. There is no direct control over UI, but there is a meta language which allows you to prepare how the SmartApp is being shown on a mobile phone. Then once the SmartApp is being started, first lifecycle related callbacks are called from the platform. Then as our devices are showing a data stream, those streams are transferred into the events and sent to the event handlers. Also, aside from the devices, there is a possibility to react to the actions taken by user via mobile phone. And basically what event handlers usually do, they invoke some special events which will be targeting some other devices. Quickly, because we are running out of time. Device handlers, this is something which is more of importance to the vendors which will be creating new devices. But basically the idea is that within the device handlers we are creating kind of the abstraction, both in terms of events and so what is happening with the device, but also in terms of the classification of the device. So what kind of actions, commands can be sent to device. So what can it do, and also attributes in terms, okay, what can be controlled on the device, not really in terms of commands. What is important, single data package coming from the device can trigger multiple events. So we need to be possibly prepared. Well, this is what should be described in the documentation for the particular device, but basically there is a possibility to create multiple events just from the single event happening or communication from the device. For the usually this is usually prepared by the device vendors, but SmartThings has also a possibility, as a company, has a possibility to support. And if somebody doesn't really want to create all this stuff which is necessary to make a device work, there is always possibility to ask a SmartThings team to help and create this for a particular company. For example, integration with Alexa has been done by the SmartThings team. Okay, so we know what we are coding, how we are coding, but where we are coding. So this is a point URL. This is an entry point for the whole SmartThings website, and it will let you work whatever is necessary with your devices, categorize them, group them, create your apps, view logs, and also create get access to the developer documentation. And in terms of creating a code, there is a web-based IDE. So this is something which fulfills a minimal necessary functionality to create a smart apps. It will be shown in more detail by Mariusz, but basically we have 3 areas. Editor, so where we are putting a code. There is a simulator, so there is a possibility, if you don't have a particular device at hand, there is a possibility to use simulators to force some activities without really touching a physical device. And there is also a log tail. So because all the information and debugging of the device, of the activities can be done only by looking through the log. So this is something which is quite important and very often used to see, okay, what the logs look like and what does it mean for my application. Okay, finally, coding demo.
Okay, let's start. Witold show you all the devices used in the interactions. Okay, you need to use my laptop. Okay, there's still no picture. Let's wait, and I will show you something. This is a motion sensor. This is the leakage sensor. It's work like by connecting to two roads, and the current will start to flow, and in this way the leakage is detected. Also, I have something interesting to show you. Do you know what is this? We call it totems. Because the smart outlet is only supported to UK market, to make it work in our country, we need to make some adapters to adapters, and we call it totems. Okay, I will connect a normal lamp to this totem to make it smart. And I will show you how to connect this everything by writing a simple Groovy script. Okay, let's wait for the picture. I may use this laptop. It's on the internet. You need to connect it. It may be faster than trying to do something. To prepare, I will put this sensor here, so the motion will be detected now. Oh, I also have this SmartThings hub. It's quite nice. You can put it in the on the shelf, on wherever you like, or put it on the sailing, so it's white, it's okay. And this SmartThings has is already configured to work with those sensors. Okay, let's start. Maybe I will use my mouse. Yes. Okay. Okay, I need to connect the. Okay, I'm connected to internet. Let's start. No, it may be hard for me to code on this big screen. Okay, let's start with. Okay, this is this graph site. It's for sites for developers where they can create their own code. I will log in. What kind of keyboard is this? Maybe this way. Okay. How to make this monkey sign here? Okay, I will use my.
Shift like this.
Let's change to the other language.
Yeah.
Maybe here. Alt Shift. Let's see. No. Control Shift. Oh, done. Oh, it's Russian. Okay. Oh. Try to remember my password. Okay. So let's start. I need to log to my hub by clicking this, and you see I change location to US. Okay, here are information about my house, my devices, etc. Like those sensors are defined here. Let's create some simple app. The name doesn't matter. It doesn't matter. If we want to publish it officially in the marketplace, we need to fill all those fields. But for this demo, it's not necessary. Okay, and we have some sample app. Okay, the main part. Definition is something we just filled. The preferences. Here we define the devices which will take part in our interaction. So like the sensors, the outlets, etc. There are some callbacks. They are called when we install this application, update when we update this application, and like we see after update, we first unsubscribe from all the events. So the events we will start waiting for our device will be just deleted. And then we initialize, we can subscribe to the other devices. And here we can create handlers for everything. Okay, the section title is something we will see in the mobile phone application on the page to configuration. But I will skip it for now, there's not much time. Okay, let's define some device. Let's call it my motion. In this way, this device, okay, too much presses. Again, no. We can use, when we define device something in place like this, we can use it as variable in the next part of the script. Let's add some capabilities. Okay. It's hard to see it, but this is the page when we can see what kind of capabilities our devices can have. And let's find motion sensor. And like we see, motion sensor, we need to set, when we define the device, we need to set this capability as motion sensor, and has attributes like motion active and motion inactive. And it doesn't support any commands, so we cannot tell motion sensor to do something. It's just detecting the movement. Okay. Let's add this motion sensor capability. And it's required. And let's add some title. No, it's not my keyboard. Okay, let's save it and see if everything is okay. There are no errors. And in this section, we can subscribe to some kind of events. Subscribe. First part is what sensor we want to what kind of sensor we want to subscribe. I named it my motion, so it will be like as a variable. Capability. What kind of capability? We have capability motion active. Okay, let's subscribe to motion active events. Motion active. And let's define some handlers. Motion active handler. In this way, every motion active event received by this sensor will invoke this handler method. Let's define it. Only one parameter as event. Okay, and let's do something like log debug and we can use some information from this event date. Let's save it and I will show the simulator. Okay, there are no errors. If there are errors, there is a big red screen information about what happened, what is wrong. Okay, if I saved, it's okay. I can deploy it to the virtual hub. I have this live hub connected with all the devices, and if I deploy this application using my mobile phone to it, it will be working. But to make development, it's easier to use this provided virtual hub. This virtual hub will also have connection to all those devices. It's working in the cloud, it's connected to this hub, and etc. Okay, so I deploy it. Okay, I will select what sensor I'm interested in, and this is only capability. Every device which is connected to our network, which has this capability, motion sensor, we can select it over there and in mobile application in future. Okay, let's install it. Oh, no motion. May someone from the first row? Yeah, motion detected. Yes, motion detected and the date. Okay, but it's not enough for us, so we want something more interesting. Let's add this smart outlet, this totem, to the interaction. I remember its capability switch. Okay, it's now okay. So it's when the motion is detected, let's turn this lamp on. So we can use this my outlet, and on this page we can see that switch capability switch. It had no attributes. It's one attribute level, okay, but he can receive some comments. Not this one, or this one. It has a state on off, and we can invoke some commands over it. Okay. Not this one. So let's do this this way. My outlet on. Just that. Let's save it. Deploy it. Let's select this outlet. Okay, now we have the sensors. I can control it from there. The lights. Maybe this is this lamp. But we want to make something more interesting. So the motion sensor is connected by someone from the first row. Oh, the lamp does turn on. But we want some other interaction. Let's add something like this. And leak. Let's add leak sensor to it. Water sensor. And it's not required, so it will be okay, I think, okay. And we need to subscribe to some events. Leak. It has water. And water leak handler method. Okay, let's define this method. Let's add some information to show that it was invoked. Something like this, and we will turn the lights off when the leakage is detected. Okay, let's save it. Yes, this is error, yeah. This kind. And there's also some error. Line 31. Leak capability. Where? This one. Oh. Okay. I love this level resolution. It's like blind man trying to do something. Okay, it's okay. Let's deploy. Let's add the OK. Capability is this way. Leakage L1. Okay, we deploy it. Let's turn the lights on. Okay, turn the lights on using motion, and it's off because I connected to two roads. For the last part, let's do some. Yeah, it's the last part, only 2 minutes maybe. Disco mode. Let's use some Groovy. Maybe it would be faster if I copy this from the working solution. I don't have much time, so I will show you the completed script. When we did detect leak, the lamp, okay. I will deploy this finished application. The lamp should blink 5 times. Simulator. I need to undeploy this old one. Let's select the sensors. Installed. Okay, let's make a leak. It's done by the simple Groovy script, and using run it, it's something we can provide the time when should you run in the which time and what handler should be called. Also, we can make maybe there is something like I have some example how to make a REST call from this application. Here is the response data received, and here is the part of the code responsible for making a call. We define some call parameters, and we use the HTTP GET method, and the response is parsed to this response data. Okay, I don't have much time. I have some other interesting thing presented, but I think it will be enough. Thank you very much.